Hey everyone, and welcome. Today, we are diving deep into Python's logical and bitwise operators. Now, these are the tools that really control the flow of your programs, and you're going to see how they power everything from a simple decision all the way to some surprisingly clever code. Let's get right into it.
So I'm sure you've written tons of if-else statements, right? But have you ever stopped to think about what's really happening behind those conditions? Today, we're going to move way past the basics to really understand the tools that give you that fine-grained control over your program's logic and data. This is where you go from just being a coder to a real programmer.
Okay, first up, let's start with the familiar stuff. These are the three logical operators you're probably using all the time to combine and check conditions. They are the absolute bedrock of decision-making in your code. The difference here is really simple, but it's absolutely crucial. Think of and like a strict bouncer at a club. You need your ID and your ticket to get in. No exceptions, both have to be true. Or, on the other hand, is kind of like a coffee shop that takes cash or card. As long as you have one of them, you're good to go. And then you've got not. This one's the easiest of the bunch. It's basically just a flip switch. If something is true, not makes it false. If it's false, not makes it true. It's super useful for checking if something isn't there, like, if not user is logged in. All right, now this is where things get really interesting, and honestly, where a lot of sneaky bugs can creep into your code if you're not paying attention. Just like in math, where you have PEMDAS, Python has a very strict order for evaluating these logical operators. And trust me, the sequence matters a lot. So take a look at this line of code, true or false and false. What do you think the final result is going to be? Now, your first instinct might be to just read it from left to right, but that's not how Python sees it. So take a guess. What do you think? Let's find out. So here's the secret. It all comes down to this hierarchy. Python will always evaluate any not operators first, no question. Then it goes and finds all the and operators and takes care of them. And only at the very, very end does it deal with the or operators. So remember that order. Not, then and, then or. You got to commit that to memory.
Okay, so let's apply that rule to our puzzle. Python sees the and first, so it evaluates false and false, which of course becomes false. The whole expression then simplifies down to just true or false, and since or only needs one side to be true, the final result is true. See? This is exactly why knowing the order of operations is totally non-negotiable.
Okay, we've covered the high-level logic. Now let's go deeper. We're about to pull back the curtain and look at how computers actually think. We're moving from the abstract world of true and false down to the binary reality of ones and zeros. Now, you might be asking, okay, but why do I actually need to know this stuff? Well, bitwise operations are like a secret weapon for performance. Because they work directly at the binary level, they are blazing fast. This makes them absolutely essential in fields like graphics, cryptography, and pretty much any kind of embedded systems or hardware programming. So, to work at this level, you get a very specific set of tools. These are the bitwise operators. We've got and, or, and a really special one called XOR, which stands for exclusive OR. Let's break down what each one does. The bitwise AND, which is just a single ampersand, is a lot like its logical cousin, but it operates on a bit-by-bit level. For each position in two numbers, it asks a simple question. Are both of these bits a 1? If the answer is yes, the resulting bit is 1. If not, it's a 0. Let's see this in action. Check out the top row, 1101. That's the number 13 in binary. The second row, 0111, is the number 7. Now, looking down each column, the AND operator only puts a 1 where both rows have a 1. That only happens in two spots, giving us a result of 0101, which is the number 5. Next up is bitwise OR, which uses the pipe symbol. This one's way less strict. It looks at each pair of bits and returns a 1 if either of the bits is a 1. It's often used for things like combining settings or just flipping specific bits to on. Let's watch it work with the numbers 10 and 6. For the first 3 columns, at least one of the bits is a 1, so the result gets a 1 in those spots. It's only in that very last column where both bits are 0. So our final binary, 1110, gives us the number 14. And now for XOR, which uses the caret symbol. This one is really unique. It gives you a 1 only if the two bits are different, meaning one is a 1 and the other is a 0. If they're the same, whether they're both zeros or both ones, the result is 0. Just think of it as the one or the other, but not both operator. So let's try it with 18 and 9. Comparing them bit by bit, we get a 1 wherever the bits don't match. You can see that happening in the first, second, fourth, and fifth columns, and that produces the binary for the number 27. Now, pay close attention to how this one works. It is the key to a magic trick we're going to do in a minute. Okay, so besides just comparing bits, we can actually move them around. These next 3 operators are really powerful shortcuts for flipping and shifting entire sequences of bits all at once. The bitwise not, that's the tilde symbol, is really simple in concept. It just inverts every single bit. Every 1 becomes a 0, and every 0 becomes a 1. Now in Python, because of the way it handles negative numbers, this ends up following the formula shift x equals negative x plus 1. That little bit of math is why shift 5 actually gives you negative 6. Bit shifting, this is an incredibly efficient way to do math. Shifting bits to the left is the exact same thing as multiplying the number by 2 for each position you shift. And shifting to the right, well, that's the same as dividing by 2. This is often way, way faster than using the normal multiplication or division operators. Okay, theory is great and all, but let's put it all together with a classic programming puzzle that honestly feels a bit like a magic trick. This is a fantastic way to show why understanding these operators, especially XOR, is so powerful. So here's the challenge. Imagine you have 2 variables, A and B. How do you swap their values? Now, the easy way is to just create a third temporary variable. But here's the catch. You can't. You are only allowed to use A and B. So, how would you do it? And the solution is this really elegant 3-step swap using nothing but XOR. Here's the key property you have to remember. If you XOR a number with the same value twice, it cancels itself out. So in step 1, A becomes a combined mask of both of the original values. In step 2, we use that new mask to isolate the original A and put it into B. And finally, in step 3, we use that mask one last time to isolate the original B and put it into A. It's a beautiful, super efficient way to swap values right in place.
And that brings us to the end of our look at Python's logical toolkit. You know, as the great B.B. King said, the beautiful thing about learning is that nobody can take it away from you. Now that you know how to work with bits directly, where else in your own code could you use these powerful shortcuts? Thanks for joining me.